everybody. My name is Clare Sudbery and I'm going to be talking about continuous integration. I will show this QR code again at the end, but you can use this QR code to give feedback on the talk, and I'm always interested in hearing feedback. I pretty much never do exactly the same talk twice. I'm always looking for ways to improve things. So feedback is very useful in that process. You can also download these slides. I know the conference is also going to make them available, so I've actually been given a stick to put them on when I'm done. So you'll be able to get them via Agile on the beach, but you can also use that QR code, which I will also show at the end. Okay, so what is continuous integration? You can tell by the title that I'm going to suggest that the current understanding of continuous integration might not match the original definition. So let's start with what I think continuous integration is, and I'm going to ask you all to stand up. Get the blood flowing after your night out on the beach last night. Okay, stay standing if you do continuous integration where you work. Okay, good few people. Stay standing if everyone on your team commits and pushes to a shared main source code branch at least daily. Everyone. Okay. Stay standing if every one of those commits causes an automated build and test. Okay. And stay standing if when the build fails, it's usually back to green within 10 minutes. Okay, well done. You can sit down. So that was Jez Humble's continuous integration test. The joke is that there is continuous integration certification available. If every developer commits at least daily to the shared mainline, if every commit triggers an automated build and test, and if build and test fails, it's repaired within 10 minutes, then that's continuous integration. And that's what I mean by continuous integration. It's not what most people mean by continuous integration, and it's not what most of the products out there mean by continuous integration. So products that have CI in their title, they don't necessarily mean that. But that is what Kent Beck meant when he first defined the term in 1999 in Extreme Programming Explained. He says, no code sits unintegrated for more than a couple of hours. At the end of every development episode, the code is integrated with the latest release. So that doesn't count as if you have it sitting on a branch. That's not integrated with the latest release. So, and this is who I meant by they when I said that's not what they meant. So it was Kent Beck and his cohorts at the time who first defined the term continuous integration. And while we're here, I want to draw a distinction between continuous integration and continuous delivery. Continuous delivery is where not only is the code being continuously integrated with the rest of the code, but it is actually being deployed in a way that means it can be used by users continuously several times a day. It is possible to have continuous integration without having continuous delivery. As far as I'm concerned, continuous integration facilitates continuous delivery. So I think continuous delivery is also a good thing. But the topic of this talk is continuous integration. So I just want to draw that distinction. Some people also talk about continuous deployment. Some people draw a distinction between continuous delivery and continuous deployment, but that's quite niche. Most people don't. I don't, to be honest. You can if you like. But I'm talking about continuous integration. So you can also call my definition of continuous integration trunk-based development. And that's what I tend to call it. Because of semantic diffusion, because the term continuous integration has started to mean different things to different people, I find trunk-based development to be a more descriptive term. So what I mean by trunk-based development is that all code is being integrated, is being pushed to the main line, which used to be called the trunk in some older version control systems. actually most people don't call it the trunk anymore, but when I say trunk, I mean the main line, which also sometimes used to be called the master branch. What I'm saying is that all code is going to the main branch. It's not sitting in feature branches. And I will tend to use that term. Martin Fowler doesn't like it. He prefers continuous integration. He thinks it's disrespectful to Kent Beck and the people who originally came up with it to try and use a different term. But because the definition of CI is a bit muddy, I prefer TBD, trunk-based development. So my claim is that if you use trunk-based development, you will be better, faster, and happier. Better quality code, faster delivery, and happier developers. Happier because better and faster means more satisfaction, but also because trunk-based development facilitates and necessitates better communication and closer collaboration. And that, I believe, tends to lead to a better development experience. But I'm not the boss of you. You don't have to do what I say. I'm not here to wield a big hammer and hit you all on the head if you don't do continuous integration. I'm not here to judge you. A lot of people think that people who like to talk about trunk-based development are just really annoying people who are just going to keep telling you off all the time. There are many reasons why people don't do what I would call continuous integration. I'm not here to have a go at you. I'm just here to extol the benefits and the virtues of continuous integration and maybe persuade you that it might be something that you want to think about, or if you think you're already doing it, to improve the way that you're doing it, to get closer to the original definition. And if you are already, if you're one of the people who is still standing at the end, fantastic. Hopefully what I can do is make you feel great, but also give you some arguments that you can take back to colleagues who might be less convinced or who might still need a little bit of a help. So my argument is that if you're using feature branches or any form of branches, what they can do is slow you down and increase risk. And I'm going to make this argument by telling you a story. I am also a published novelist. And when I was writing my novels, I read this book, Story by Robert McKee, which is a great book. Highly recommend it to anybody who is not only writing fiction in the printed form, but also people who are playwrights or screenwriters. In fact, he wrote the book for screenwriters. He himself was a screenwriter. But what he talks about is how to structure a story in such a way that you keep your audience engaged. And I love to tell stories. I find storytelling is a useful way of delivering information. And one of the things that he talks about is that every small chunk of your story, so if it's a film, every scene, if it's a book, every chapter or even subchapter, should have a start state, a turning point, and a new state at the end. And that's how you keep your audience engaged. Things keep changing. You're pulling them forward with you, and things are happening. So it's not just random things are happening, but things are happening to change things. So things change as a result of the things that happen in your stories. And I'm going to use that structure very broadly to tell you a story where on each slide there will be a start state, a turning point, and an end state. And what I'm going to do is I'm going to tell you a fictional story of a development team on their journey towards continuous integration or trunk-based development. So my fictional team is very new. They're working on a new product. They haven't been going for long, but up until, for a few weeks maybe, but up until now, they've been using branches. And what they've been finding is that every time somebody finishes work on a branch and then tries to merge it back into the main line, there's merge hell. It causes lots of problems. It slows everything down. And they think they've managed to merge it successfully, and then it turns out they've obliterated something that somebody else did. Things are now broken. Things aren't working. It's causing them pain. One of them has read an article about trunk-based development, might even have been the one I wrote for O'Reilly, and they come back to the team all excited and say, we should do trunk-based development. We're all going to do trunk-based development from now on. No more branches. Hooray. Okay. But somebody else comes in and says, no, you can't, because we wouldn't be compliant if we did that. There are various hoops that we have to jump through in order to be compliant with standards such as HIPAA or SOC 2 or ISO 27001. And so we need branches because we need pull requests and we need code reviews. And we need to be able to audit where this code is coming from rather than it all just arriving back in the main branch willy-nilly. So they go back to branches. And now they have branches and they have pull requests and they have code reviews. And this is leading to a lack of trust in the team because now the default is every time you finish your work, you have to have it overseen by somebody else. And the people who are overseeing it feel like they're not doing their job right if they don't find fault. And now particularly newer developers are really paranoid, they're really worried. And because that builds and leads to more of a lack of trust, that leads to more pull requests and more nitpicking and even more lack of trust. So now that we've got even more pull requests and even less trust, we're moving really slowly because everybody's worried. Nobody wants to merge their code back into the main line because they know that'll be a pull request and a code review, and that leads to being told off constantly, and nobody trusts each other's code. So this is where I get on my high horse a bit about pull requests and code reviews. I used to work for ThoughtWorks, and I still hang out on a couple of Slack groups where there are a bunch of people who do or did work for ThoughtWorks hang out. And I asked them, what do you people think of code reviews and pull requests? And I got a deluge of responses, negative responses, people who don't like them. So Dan Abel said, PR feedback is the last point in the dev cycle where feedback is useful and often the most wasteful. Keith Morris, who is, I don't know if he's in the room because I can't see you all that well, but he's been at the conference this week. This is from his book. He says, using pull requests for code changes by your own team members is like having your family members go through an airport security checkpoint to enter your home. It's a costly solution to a different problem. So the origin of pull requests comes from open source. And if you're working on an open source project, then you're inviting contributions from people you know nothing about. So you do need a gateway. You need some way of checking the code before you integrate it with your code base. And that's where pull requests are really useful. But in a trusted team of developers who know each other and are working together closely, pull requests can reduce trust and cause problems. Dragan Stepanovic, in a great talk that I saw him do at Newcrafts, I think it was last year, said that he did a really interesting piece of research. There is a link to his article about it on this slide and also in the links at the end. He says the bigger the pull request, the more likely it will suffer from the so-called looks good to me syndrome. So if the pull request is big, if it's been a really long-lived branch with lots of lines of code changed, it's more likely that people just go, I don't know, seems all right. And reviewers have less incentive to build in the quality. But if the pull request is small, which is actually what I would argue for, I think the smaller the better if you're going to have pull requests. And I understand that people, for a lot of reasons, do have them. Then it's more likely that people, because there's only a few lines of code, so it's a lot easier to go, oh, I don't like that one, and actually find the time to look at it properly. And then we get back to what I was talking about before, that people feel like they have to do their job, so they have to find something wrong with it. And Dave Farley says that my experience across the board has been that regulators prefer these approaches, trunk-based development, continuous integration, once they come to understand them, because they provide a better quality experience all round. So this idea that you're not compliant if you don't have pull requests and code reviews is not actually true. If you look at the letter of all of those standards, they don't say you have to have pull requests. They talk about accountability, they talk about being able to audit, but they don't specifically say that you have to have pull requests. What Dave Farley does with the teams that he works with is he points to what the value you get from a good automated pipeline with good tests. And that's actually much more traceable and much easier to look at than pull requests, which are very organic, very manual, and very variable. And And sorry, my mind has gone blank. I was going to say something else about that. But so what he says is that he works closely with auditors, he works closely with people, and he shows them that the benefit they're going to get from automated systems, and persuades them that actually this is better for all the reasons that I'm going to go through, because your code is being integrated quickly, it's not sitting somewhere else for a long time, you've got less risk when you're merging, you actually get a better experience. Oh, and the other thing I was going to say is that all of those standards aren't saying that you are not allowed to have bugs in your code, because we all know that's impossible. And I'm not going to claim that a good continuous integration system means no bugs. I think it means fewer bugs. But there are always going to be bugs. There are always going to be issues. Compliance is not about removing bugs. It's about being able to fix them when they arise, and being able to trace your processes back. Dave also says the more complex the compliance mechanisms around change, the lower the quality of the software. I believe that it is not possible to implement a genuinely compliant regulated system in the absence of continuous delivery, which you can't do without continuous integration. So there's this thing about complex compliance mechanisms. The more hoops people have to jump through in order to get their code into production, the more delays and the more risk, and the harder it is to verify quality. Okay, so people then say, whoa, hang on a minute, you're talking about code reviews and pull requests, but surely we need some mechanism to review our code. And yes, absolutely, it's a great idea to review your code. It's a great idea for as many eyes as possible to see your code. And a lot of the time, the compliance standards talk about how many eyes have seen code rather than how those eyes have seen it. And pair programming and mob programming, or as I like to call it, ensemble working, are very good ways of getting multiple eyes on the code. They're also great ways of doing code reviews. So rather than every single piece of work resulting in a pull request and a code review, which is quite bitty and necessitates a lot of context switching. So somebody who's working on something completely different has to come and get their head into what you're doing and make sense of it. And that's often quite hard for them. A better approach is to get together at regular intervals as a team and review recent changes and have a look at the current state of the code base and tell each other what you've been doing. And also the benefit of ensemble code reviews and ensemble work in general and pair programming in general is that you get to talk about what you're doing while you're doing it. So that thing that I think it was Dan Abel said about PRs being the most wasteful point to get feedback, because once you've finished working on a branch, you've already done the work. Which is another reason you get the looks good to me syndrome, because your colleague knows you've just spent 2 weeks, 4 weeks, however long, working on this feature, and they know that you've already finished it. So now for them to say, oh, actually, I think you should rip it all apart and start again, not helpful, not useful, not effective, not efficient, they're not likely to do it. Whereas if they're working with you as they go along and they spot that you're disappearing down a rabbit hole, or you spot that each other are disappearing down rabbit holes, then you can correct as you go, rather than waiting to the end. Okay, so back to our fictional team. There's been an explosion of PRs, a lack of trust, they're moving really slowly. And somebody remembers again that article about trunk-based development. They've also read Dave Farley's stuff about continuous compliance. And they've decided, no, we're doing it. We're going to do trunk-based development. No more branches. Now, this is what I'm calling big bang trunk-based development, because they're just doing it suddenly with no preparation, no thought about how they're going to do it. They've just decided they're going to do it. So all of those branches are just going to be thrown away. Everything's going to go into the main line as soon as it's finished. But up until now, they haven't been writing brilliant unit tests. They don't have an automated test suite built into their pipeline. Their testing regime is entirely manual. So they can't deploy. So they've got all this code that's being integrated all the time into the main line, but they can't deploy it because they have to test it. And that takes time. So they're not getting the benefit that they wanted from it. So the combination of big bang trunk-based development and manual tests means that they're now saying, well, we have to continuously deploy this stuff, so let's just get it out there. We won't test it. It'll be fine. So, of course, you know, It's problematic, whole system failure. Now everybody's blaming everybody. They're all miserable. Everything's going horribly wrong. This has not worked. And where there's blame, there's probably guilt and shame. And they work out that actually, maybe they need a bit of help with all of this stuff. Now, this is a blatant plug. I happen to be a member of the Saman Technical Coaching Society, which was founded by Emily Bache. This is a fantastic book if you're interested in technical coaching. This is from the foreword of that, the introduction of that book. The foreword is actually by Ken Beck, who's the person was pretty much the they in the title of this talk. But Emily says, in order to be successful in modern development organizations, software developers need new skills. These skills are not easily learnt on a short training course or at a university. Practices like continuous integration and test-driven development, which I'm also going to argue is very useful if you're going to do continuous integration, require developers to change their minute-by-minute habits and ways of working. And having a technical coach, having somebody experienced, doesn't mean you have to hire me or one of my colleagues or somebody like me. Technical coaches can be internal to an organization. They can be trained from within. They can be part-time. But having experienced people who work with teams to help them develop and learn the practices they need in order to do effective continuous integration can make a huge difference, because you can't just do it. You're probably already thinking, well, how am I going to commit my code to the mainline when, I haven't finished it yet? Well, actually, you have to code in a different way. And that is a skill that can be learned. So also, this is from Ken Beck, from the foreword for Emily's book. Software development is best seen as a learning process where running programs are the proof of learning rather than a factory or production process. Walking a new path together along with an experienced guide reduces the time spent not learning because of fear. And I've got a whole other talk about how fear impacts developers' ability to work effectively. So they've now got some help, and their technical coach has encouraged them to start pairing together and working together and highly collaboratively on the work that they're doing. So sometimes they're doing some pair programming, sometimes they're doing some mob or ensemble programming. And as part of this whole process, they're also learning how to be really good at test-driven development, refactoring, and automated testing. But the code that they originally wrote was written without using these techniques, and it's tightly coupled. So it's not very well factored. And this means that their builds are really slow because all of the code is connected to all of the other code. If they want to build one bit of the system, they have to build the whole system. And if your build is slow, then your tests are going to be slow because you can't run tests until you've built the code. But just the slow builds means that this is not going quickly, because ideally what we want is to be able to write code, integrate it with the rest of the code base, and get it out there as quickly as possible. Now, as I said before, I'm not necessarily talking about continuous delivery. So when I say out there, I just mean get it in the hands of all the other developers on the team, literally integrated with all of the other code in your code base so that everybody's using and working with the same code. You want that to happen as quickly as possible. That's not going to happen quickly if your builds are slow. So they minimize the dependencies. They refactor the code base. They make it more modular. There are lots of different ways of making code modular. This is not a talk about architecture. But the more modular it is, the less tightly coupled it is, the quicker your builds will be. So one of the interesting things that you'll notice about continuous integration is it doesn't really work without all of these other practices. And all of these other practices encourage you to write really good code and have a really good code base. So not only does continuous integration rely on really good software development techniques, it encourages them, it necessitates them, and it facilitates them. So, and this is from the book Accelerate, which you may know, which was written by Nicole Forsgren and a bunch of other people, and Jess Rumble, in fact. And this was based on the results of the annual DORA reports, which, if you don't know of, they're worth looking up. And these are reports that are run across the whole industry. They're really, really deeply researched about what makes a difference to effective software development and delivery. they're almost, I mean, I would say, and having not read every single piece of research out there, so I can't say for sure, but, and a lot of other people say, the most rigorous research that there is out there about software delivery. And it's really difficult to do research into software delivery because there are so many variables. But they've tried really hard, and they say continuous integration requires relentless work to simplify systems architecture on an ongoing basis to ensure that this automation isn't prohibitively expensive to create and maintain. So it facilitates and necessitates constant review of your architecture and making sure that your code is well factored. This is the book that I was just talking about. There'll be a link on the links slide at the end. So they've now minimized their dependencies. But this now means that their code is split into more modules, and that can slow your tests down because now you're running an awful lot of tests every time you need to run your tests. But that, again, doesn't have to be the case. So one of the things that continuous integration does rely on is fast tests because you want your code to get back into the main line quickly, and you want to make sure that it isn't going to break anything. So you want a good suite of tests running automatically, but you also want to make sure those tests are passing before you move on to your next piece of work. And if you have to wait ages, then that's really painful. So it also, again, necessitates and facilitates people speeding up their test suites. There are lots of different things you can do to speed up test suites. Again, that's not what this talk is about. You can run them in parallel, but you can also have incremental test software that only runs the tests that have been touched and impacted by the code that you've just written, rather than running the whole suite of tests every single time you push a change. So that's what I'm calling incremental tests. So now they've got a good, fast suite of incremental tests, and they've got into the rhythm, and they're so used to just pushing everything to the server constantly, and there's an automated suite of tests running on the server. They get out of the habit of running tests locally on their own machine before they push changes. So this means if the tests are failing, they don't find out until they've already pushed the code and it's on the server and it's failing on the server. So now the pipeline's broken, the build's failing. And so the build keeps being broken because people haven't been running tests locally. So the solution to that is people get into the habit of running tests locally, which is a really good habit, and also will necessitate and facilitate fast test suites because it's really painful if you have to run a slow suite of tests locally every time you want to push a change. So now they've started running tests locally, and they've agreed as a team that they're going to always keep the build green. So that was one of the things that was mentioned in the continuous integration certification test at the start. That's why it's important to keep your build green, because this has to be meaningful. You're not just pushing your code to the mainline, you're pushing and integrating it in a way that means it works and is now available to all of the other developers, which means that the build has to be green, the tests have to be passing. But some people, some maybe possibly quite often newer developers to the team who are a little bit nervous and are worried that this code that they're writing might not be good enough and that they might break the build. And so what they're doing is, instead of pushing frequently, they're keeping it, they're kind of hoarding it on their own machine. So they might, you know, in the worst case, they might start work on Monday on their copy of the main branch, and then they don't push until Friday. Well, they may as well be working in a branch because they're not integrating with everybody else's version of the main branch. So now we're back to merge hell, because the longer you keep code on your own machine, the longer the period of time between you writing something and you merging it with the rest of the code base, the more likely it is that changes made by other people in the meantime will cause merge problems. So now what they do is they learn about MMMSS, which I'm going to explain, and they start pushing frequently. So hopefully the next slide, yes, the next slide is about MMMSS, which is quite hard to say. MMMSS stands for many more, much smaller steps. And this is one of Jeepor's inventions. And if you haven't come across, Tommy didn't invent the concept of working in small steps, but he invented the phrase. If you haven't come across Jeepor, looking up, he's fantastic, wonderful, wonderful man with lots and lots of really interesting, useful things to say about software development. The idea of many more, much smaller steps is that everything you do gets broken down into really small steps. And every step goes from good to good. So you go from working code with tests passing to working code with test passing. And this is one of the fundamental skills that developers need to learn in order to do continuous integration. And it's not a skill they necessarily have. It's not a skill that's necessarily taught in university. It's not a skill that's necessarily being used daily by most developers. It's really common for people to work in such a way that they basically pull everything apart. It's like pulling the car engine apart and having all the pieces laid out on the floor, and then somebody says, I need to go to the shops. It's like, not going to be able to because I've just pulled the engine apart. A lot of people work like that when they're writing software. They break everything. It's not building. The tests aren't running. Certainly can't integrate it back with the mainline, but you don't have to work like that. It is possible to work in tiny steps. The smaller, the better. And GPO's got loads to say about it. And again, I don't have time to go into it, but there are lots of reasons why the smaller the steps you work in, the more agile you are, the more flexible, the easier it is to actually get from A to B. If you're able to dot about rather than just going, I'm going to do that and it's going to take me 2 weeks. Okay, so now they've learned about MMMSS. Tricia says integrating small changes regularly into your code is usually less painful than a big merge at the end of a longer period of time. So now we're really doing what I would call continuous trunk-based development. So I'm calling it continuous because of what I said before about it's possible to do trunk-based development but have somebody have their own local copy of the mainline sitting on their machine for 2 weeks. So that is technically trunk-based development, but it's not continuous. So I'm going to qualify it and call it continuous trunk-based development, where you're regularly merging your changes back into the remote copy of the main branch. Now, there still might be merge issues. It still might be that somebody made a change to a file in the last 2 hours or the last 10 minutes since you made a change, and their change has got to main and your change gets there, and there's a merge problem. But if it's only 2 hours or 1 hour or half an hour or 10 minutes since the last time you pushed your changes, you can just throw what you did away and do it again. It's still fresh in your mind. And often it allows you to revisit what you've done. And quite often the second time round, you do it slightly better. So those minor merge issues are not anything to worry about because it's so easy to just throw it away and start again. Or maybe you can fix the issue. It's also a lot easier to fix the issue when the changes made were very small. So there's not a lot to worry about. So what about feature flags? I haven't mentioned yet a question that is quite likely to be in at least one person's head, which is, but, okay, so I'm making really small changes and the test is always passing and the code is always compiling, but I'm in the middle of writing a feature. It's not finished. I'm not ready for people to use it. What about that? And so the first answer to that question is actually surprisingly easy to write code that is not finished but does not break the code base and can be integrated. You can have classes sitting in your code base that aren't called or used by anything. They're in development, but they compile their tests pass, the tests that have been written so far pass. And it's also possible with UI stuff. So it's possible to have UI stuff that gets turned on or off. It's possible to have UI stuff that there isn't a button yet that you click in order to see it, so only the people who are working on it can see it. And there are lots of ways of having things be integrated into a code base, but not yet being used by users. Then again, it's also a good idea to work in such tiny chunks that actually a really small piece of work can be used by users. But 10 minutes worth of work, 2 hours worth of work, probably not. So the default answer is feature flags, and I've just realised I put this slide up while I was talking, so you've already read what GPO's got to say about it. Feature flags are useful, can be useful, but you have to be wary. So what some people do is they say, oh, it's fine, we'll just put everything behind feature flags. So really, it's kind of a branch through the back door. I'm saying, I'm working on this thing, and I've been working on it for the last month, but it's behind a feature flag, which means that it's not really integrated with the rest of the code base because it never gets called. The other developers are barely aware of it. And we've got 1 million of these things. And it's now really complicated because if you think about it, if you've got 100 feature flags, which can happen, and any one of them could be turned on or off, if you know anything about maths, the number of possible combinations of features is really, really big and not testable manually, and quite difficult to test it in an automated fashion as well. So you have to be really careful with feature flags. And what GPAW says is to get maximum bang for your TBD, as in trunk-based development, buck, all developers all the time should be running with 100% of the features turned on. A great deal of the benefit of continuous integration and trunk-based development both is in the extensive pre-testing workout the code gets as it's used by the rest of your team. So yes, feature flags at the front end are where they're most useful, that your testers can turn on and off, or that your product owner can turn on and off, and ultimately can be turned on and off in what's being released to your users. But keep it to a minimum, because it can explode and it can create as many problems as it solves. Okay, so conclusions. How are we doing for time? Okay, I've been going a long time. So this was also one of my ex-colleagues, Eli. They said, we use branches when we don't mob or when we modify shared code. Nobody likes using branches, which in turn encourages us to mob more, so work in a more highly collaborative way. And I'm not the boss of you, but Dave says any form of branching runs counter in principle to the ideas of continuous integration. Don't branch, don't branch, don't branch. Just saying. Okay, so why does it make better? The benefits are that you get to work in small steps, you get fast feedback, you avoid merge hell, you reduce risk because it's much less likely that the code you deploy causes problems. Faster integration means fewer queues, collective ownership of the code, better quality code. There is tons of evidence in the DORA metrics and the State of DevOps and the Accelerate book, where they do every year recommend trunk-based development. And in fact, there you go. They say it's been shown for years to accelerate software delivery velocity. And here's a summary of the techniques. You can do some of these things without doing all of them. So you can start down on a journey towards continuous integration. And even if you never get there, you will likely improve your software development practices as a result. So automated incremental testing, minimize dependencies, speed up your tests, make sure the build is always green, build and test on your own machine before merging to a remote server, push frequently, use test-driven development, refactor frequently, throw things away, use many more much smaller steps, get help, build trust, collaborate, be patient, have interactive code reviews rather than individuals sitting on their own, looking at somebody else's code. And if you have all of that, then maybe you can avoid using feature branches and maybe even get rid of pull requests. Bunch of links, which you can get the slides and then you'll get all of the links. This is a podcast that I hosted. There are 27 episodes and relevant episodes are Emily Bates on refactoring, G. Paul Hill on test-driven development, and Mary Williams on changing legacy systems. Each episode is me interviewing one of these fantastic people. And I also wrote this report for O'Reilly, What is Trunk-Based Development? And you will get all of that if you scan that QR code. This is who I am. I help teams to improve their software delivery. I do coaching, keynotes, workshops, bunch of links there. And this is the link that will give you these slides, which will also give you all of those links from the slides. Do we have time for questions? Because somebody said there was going to be a clock, but there you go. Does that mean I've got 6 minutes left? Yeah. Amazing. Fantastic. So I don't know why I know why it is. It's because I started sharing these slides when I arrived in the room, which was apparently 52 minutes ago. But I've still got 5 minutes and 44 seconds left. Fantastic. So, are there any questions? Loads of questions. Right, your hand went up first.
Probably got at least three, but I guess one question would be if historically you'd have someone working on a feature plan to work with for a month in university, that's a bad thing in terms of this, but then you decide not to go ahead with that feature. It's quite easy to refer it out.
Mm-hmm.
So if you've had someone who's been working, doing commits to mainline for a month, and then this is just not going to work, pull it back out. I guess you can do one change then, that basically you need to make sure that you've just actually done one commit to roll it out. But you can't revert individual ones. Does it make it harder to pull things out?
So the question is, if somebody's been working on a feature branch for a month, and they've now committed it at the end of that month, but then the decision is actually this is not working. We don't want this in the code base. We want to back it back out. If there was a feature branch, it's quite easy because it was just potentially one commit at the end of that feature, and you can just revert that commit. I would love to meet people who have actually been able to successfully do that, because in fact, reverting that one commit at the end of that feature is rarely as simple as that sounds, because typically when you decide to do that, more code has been merged on top of it, and actually it's not that easy. But let's say it is. Let's say you've got that one commit and you can just revert that feature. The fact that you're thinking like that means that you're still thinking in the way that people think when they work in that way. If you work following the MMMSS paradigm, where you're always making tiny changes and you're working highly collaboratively, so you're not working on your own, the rest of the team is aware of what you're doing, and you're writing highly modular, loosely coupled code, then it's not that difficult to say we don't actually like that bit. Typically, quite often, in the result of developing a feature, somebody has refactored, particularly if you're in the habit of daily refactoring and constantly refactoring. As part of that feature, some useful refactors have happened, and you probably don't want to throw it all away. But you might say, we don't want to use that bit of the functionality. Now, if you've written your code in a modular way that's well tested and has good APIs and good contracts between all of your classes, you can just say, we're just not using that. We just won't use it. And if there's a whole class, for instance, that you just like, actually, you know what, doesn't do what we wanted it to, we don't like it after all, throw it away. And it shouldn't break anything. So but people get into this way of thinking that here's my bit of work and here's my commit, and we either have it or we don't. And actually, it's better if you're working in small steps, you're doing little refactorings, you're adding little classes, you're adding little tests, you're doing a bit here, a bit there, and you end up with something that the user can see, which again, might be turned on or off by a feature flag, or there might just be a button on a page that you just take off and it no longer calls that bit of the code. One habit that people do have, and I have, is hoarding, where you're like, we're not using it anymore, but we'll just leave it in the code base in case. That's not great. You can throw things away. And also with version control, you can get it back again. Yeah. So, yeah?
My question would be, do you encounter any teams that change their way of working to be continuous countries development, but found out it's just not for them? They didn't like it after all and reverted back to the previous way of working?
Oh, okay. So the question is, have I encountered any teams that tried trunk-based development, didn't like it, and reverted back to previous ways of working? I haven't personally encountered that, no. So in my experience, when people try it, they love it. And it does take time. You know, I mean, like I said, you need to be good at a lot of different things, and you need to learn how to do those things. You can't just do it. And people often don't get all the way there. You know, they implement some of those practices, but they don't quite get as far. And there are lots of reasons why people don't get all the way there. I think what can happen is that people who aren't used to being highly collaborative, so they aren't used to practices such as pair programming or ensemble work, and people who aren't used to test-driven development don't like it. It feels weird and unnatural, and also they get that feeling, which I totally understand because I've had it, of there's people looking over my shoulder the whole time. I just want to go and sit in a corner and write code, and I don't want to have to deal with people, and you're making me pair with people, and I don't like it. A lot of people have that feeling, and it does take time to get used to it. And also you have to allow for differences. You know, some people really hate pairing. And actually, you don't have to make people pair. There are other ways of working collaboratively. But often the reason people hate pairing is because they've had horrible experiences where people haven't been nice to each other, for instance. Again, pairing itself is a skill. You have to learn how to accommodate other people. You have to learn to be able to say, you know what? Right now, what I want to do is go and surf the internet and look at cats for an hour. Can we stop pairing, please? If you can't say that to your pairing partner, then you've got a problem and you're creating a situation that people are going to hate and they're not going to want to keep doing it. So yeah, there are lots of reasons it feels uncomfortable. And there are lots of things you can do to make it feel more comfortable. But if you don't, if you just kind of drop it on people's heads and say, you have to do this now, then people will push back. They will. That will happen. So yeah, you have to be sensitive.
You've got time for one very quick question.
One very quick. Is this a very quick question?
Yes.
Good.
Have you got canonical results to stop on people's noses that say we must use PRs because of regulators?
That we must use. Have I got a canonical resource to stuff in front of people's noses and when they are saying we must use PRs because of regulators? Yes, Dave Farley. So if you get these slides, in the links at the end, there is a link to Dave Farley's article on continuous compliance.
Thank you very much, Claire.